It's convenient if the axis of revolution is always the x-axis or the y-axis. It allows for the formulas involving the definite integral to be rather simple. But that doesn't mean that the axis of revolution has to be the x-axis or the y-axis. It could be some other horizontal, or for that matter, vertical line. So let's look at the situation of what if it's a line, the horizontal line that's y equals k, something other than the x-axis. So in this first situation, we have our same idea as before. All right, capital R is the radius. If we were going all from the function, which represents the upper function, to the x-axis, and then lowercase r, that's our radius from the lower function, the smaller function, to the x-axis. We're going to go around the line y equals k. So let's put in that line. There's basically two situations. The first situation is, what if the y equals k is below the region? Right. If y equals k is below the region, so let me draw y equals k right here. Here we go. If that's the situation, what have we done with our radii, in essence? Because we don't want the orange to go all the way down here. We don't want the purple to go all the way down there. We want both of the lines to stop at the green. So we need to get rid of that region right there. We need to subtract that region out. All right? We've shortened both the radii. Right? So we have to subtract. Now, how much do we need to subtract? We need to subtract that distance right there, which, oh, by the way, happens to be k units up from the x-axis. So we just need to subtract k from both of our radii. So when we're doing our integral, if we're heading around, that same idea, we still have our pi, capital R and lowercase r. They're going to be squared, which I'll put in a second, but we need to subtract k from both of the radii. After we subtract k, now we can square, we can get the difference, we can dx, and now that we have our differential, we have our formula. Now, some of you might be saying, well, what if k is below not only the region, but also what if it's below the x-axis as well? So what if instead of having this line, we have this line of y equals k? All right, well now we need this distance to be added onto the radii, which we already had. Will this formula still work? What do you think? In fact, it will, because remember what we're doing here is we are subtracting k. Up here, we're looking to add this distance. Now this distance is still k, but keep in mind what k is now. It's a negative number, because y equals k, that line is below the x-axis. So since k is negative, when we subtract that negative, we actually end up adding. So we end up adding that distance to what we already had, and we still get the correct radii, both with big R and little r. So this formula right here will work whether k is above or below the x-axis. Now what about case number 2? Not when y equals k is below the region we're interested in, but when y equals k is above the region, like this situation right here. How do we get our radii now? Because remember, what we're going around this line, so this piece, this wedge right here is actually going to come up and around, and it's going to actually, let's see if I get this, we're going to go, it's going to hit up there. Oh, sorry, that's off the board there. So we have this rather long radii, because we have to get from, basically we want this, there are these green lines, I should say. These green lines that I'm drawing right here, those are the radii we're interested in. Right? How do we get the length of those green lines? Well, we're going to have to involve k again, just like we did over here. But k is actually this distance. So we want k, but we need to subtract the r's. So instead of having r minus k, it's now going to be k, because k actually goes all the way down. All right, so it's going to be k minus the radii, all right, if we relate everything to the x-axis. Right, so instead of having the k second, the k is going to be first. Now there's another catch though. Which radii in green here is the longer one? Because remember, the longer radius goes first. Right. Yeah, this one is. And it's connected to lowercase r. So what was normally the smaller radii, or radius rather, is now going to be the larger radius. Right? So when we write our formula here, we're going to have k minus, and it's going to be little r wrapped in squared, and then k minus big R of x. And that's also wrapped in squared, minus, and the whole thing gets a dx. That's our formula if the line which we're revolving around happens to be above our region.